Hi everyone, my name is Scott Gerlinger, and for my final project this fall semester, I created an application that does virtual reality for marine evacuation training for use on facilities such as ships and offshore rigs. A little bit about myself. I am a human-computer interaction online master's student here at Iowa State. I also have a previous degree, a master's degree in modeling and simulation, also a bachelor's in mechanical engineering and mathematics. And I currently work as a senior manager at Hexagon PPM, a software company that makes Intergraph Smart 3D software, a picture of which you can see there on the screen that is used to create large industrial design. My objective with this project was to create a virtual reality application to train a ship's crew and/or its passengers on evacuation routes to follow in cases of emergency, such as fire or flooding or some other catastrophe that requires an evacuation of the vessel. The perceived benefits listed here I gathered from a paper written by my colleague Igor Jurasik and his academic partner Abri Venter that they did for a conference in 2014. And they listed some of the perceived benefits as faster, safer, and better staff training at a lower cost, quick determination of staff proficiency and identification of where improvement is needed, quicker and more accessible navigation through the virtual ship as compared to the actual physical ship, easy and frequent visits to areas of the ship that may be physically or logistically difficult to access due to reasons such as excessive heat, noise, or poor access because it's an area such as a void or some closed off area of the ship that is not frequently visited in a normal setting. And it can also provide an enjoyable, highly immersive, and engaging training experience through virtual reality. So here's an example from the previous research. In the picture on the left, you can see where the worker has identified that a fire has broken out and that he needs to evacuate. He then runs along the offshore platform, as seen in the middle picture, and eventually reaches the lifeboat, as seen in the picture on the right, where his training is now complete. User interaction in my virtual reality application centers mostly around movement and viewing. Keyboard and mouse inputs are shown in the table here, along with the actions that are driven by them. There's movement forward and backward, rotations left and right, shifts left and right. By shift, I mean translation only, no rotation, which are all controlled through keys in the WAQ, SDE range, and through mouse scrolls and left and right clicks with movement. The camera can get tilted up and down. The camera can also be zoomed in and out. With the zoom, I enabled both the plus and minus keys as well as the equals and minus keys so that the user would not be burdened with the shift key every time they wanted to zoom in the positive range. By pressing the V key, the user can toggle between a first-person perspective view or an overhead ortho view. And the escape key is used to exit the application. The ship model that I used for this application started out extremely large and complex. I narrowed my case down to the pump room, which is just forward of the engine room, but even that had too much geometry to perform well. It took too long to load, and also the ray intersection tests were taking too long to compute. Therefore, I needed to break the model up into smaller pieces in order to optimize my ray intersection tests. So I separated it into floors, the horizontal planes on which I would run ray intersection tests to check that the human subject did not fall through, and ladders, the vertical planes that the human subject would collide with and then be able to climb up. This limited the number down from a very large model into a much smaller, manageable model that I could use. Everything else is still included, but became background structure which the human can view but not interact with. A second smaller challenge I encountered was occlusion, where the environment may block a first person, may block the first person from the camera. And so here you can see if the camera is just behind the human subject and a wall is to the right, there is no issue. But when a rotation is made, the camera may move outside to the other side of the wall. And now the wall is blocking the camera's view of the first person. In this case, I need to try to dynamically adjust the near view clipping plane so that the viewport does not include the wall anymore. Progress up to this point. For my large ship model, I've been able to generate smaller OBJ models for the floor, ladders, and background structure using 3ds Max 2018 to convert from SAT models. I generated a human model from a light wave model I was able to download from the internet. I've added ambient lighting. I was able to set the human start point and coordinate the location of the human in relation to the model and set that as a variable so that it can be changed later. I enabled movement forward and back, left and right, and rotation with the keyboard. I also enabled movement forward and back with the mouse scroll. I enabled the camera zoom, and I enabled the view change from first person to overhead and back again. And so first person will have the perspective view, and overhead will have the ortho view. Now for a demonstration of the application so far. What you'll see here was a screen capture taken from a recent run of the application. Some of the graphics will jump here because of the screen capture application that was used. So first we'll see the camera zoom in and out so that the user here can control exactly how their view looks. Then we'll move forward and back with the keyboard. You'll see this happen in more jumpy increments. And then we'll scroll with the mouse forward and back, which generally produces a smoother step. We'll rotate around, viewing the structure that is in place thus far. And then we'll walk to the first ladder, demonstrate how we can shift right and left without rotation. And then we'll switch to our overhead orthographic perspective. And now we will walk forward, continuing along the walkway. We will reach the second ladder, and then we will toggle our view back to the first person perspective. So what remains to be done? I need to add materials and texture to make the environment more lifelike, and plan to use OpenGL materials and textures, not the MTL file that accompanies an OBJ file export from 3ds Max, mostly for simplicity. I plan to add an array of light bulbs inside the model to better simulate interior lighting, and if I have time, I may add a semi-transparent texture on the camera lens to simulate smoke as if there were a fire inside the facility. I need to enable the camera tilt so that when the viewer simulates lifting their head or pointing it down, that the camera mimics it. I need to enable movement left and right and rotation with the mouse, in addition to the keyboard controls that already exist. And I may try to add an option for continuous movement with speed control so that when moving forward and back, the user does not have to do quite so much effort. I need to allow vertical movement up and down the ladders so that I can get to other levels and continue the ascent along the evacuation route to exit the ship. I need to enhance the background model with more piping and ducting and cabling and equipment to simulate the crowded situation that usually is present inside a pump room. And if I have time, I may also animate the human movement using morphing so that you can see the arms and legs move and it becomes more realistic. Thank you. If you have any questions, please feel free to contact me at the email address listed on the screen.